I'm not sure if you have ever watched this movie called Dying to Survive. So it came out in the year of 2018, and the movie is about a leukemia patient who smuggles cheap pharmaceuticals from India to help hundreds of Chinese people suffering from cancer. And in the United States, we see high drug prices are also causing problems. So cancer patients, they usually spend on average 100,000 on cancer drugs every single year. So why is the price of cancer drugs so high? And how would the PED value look like for these cancer patients? And even though understanding the pharmaceutical industry is not really required in your original IB syllabus, I think it would be very interesting for us to discuss this topic together and to see some real life implications. So the first reason behind the high price is because of the cost of research and development. And this is one of the most common arguments that is used by the drug companies to justify their high price. So it usually takes a lot of effort, time, and energy for a new drug to eventually appear in the market. It is not so easy that as you might think of. And it is not a guarantee that these research will be successful by the end. So if you think about it, it is reasonable that the drug prices are usually high, especially for rare diseases, due to high R&D cost and opportunity cost. And those pharmaceutical companies are not charities, right? They also have to make enough revenues to cover their cost. So you might wonder if the cost is so high for them, and if the research and development is likely to end in failure, what is the incentive for these firms to still continue producing these drugs? So there's the thing called patent protection, and usually lasts for 20 years long. And holding patent is extremely valuable for these drug companies. So it means that only the pharma company that holds the patent is allowed to manufacture, market the drug, and eventually make profit from their own invention. And during this period of time, prices are usually said to be extremely high for the drug companies to earn enough revenue to cover their original cost. So once the period for patent protection expires, then the drug is allowed to be manufactured and sold by other companies. But still, there are a lot of remaining questions. So why are cancer drugs so expensive compared to other drugs? And if the patent length is limited, why do we see lasting high prices in the cancer drug market? So below I have attached a paper written by Dr. Vincent Rajkumar, and some of his findings from his paper actually answer the question that I had. So today I'm going to share with you. So first, he rejected arguments that are usually used by the pharma companies to justify the high price of cancer drugs. And Dr. Rajkumar said the research and development cost is not as expensive in reality. So a company usually claims that it costs $1 billion for each new drug to be developed. But actually developing new drugs only costs about 10% of this amount that I originally claimed. And another thing that he mentioned in the paper is, unlike antibiotics, the cancer drugs are different in a way that they don't represent a competitive market. So previously, when we study chapter 7.3, we know that a competitive market implies the absence of oligopoly or monopoly. Say if you have a fever today and there are 10 different options in CVS that are available for you to choose from, and when one of them can successfully treat your illness, you won't really need the other 9. So that will make the prices reasonable because of this genuine competition. But for cancer drugs, even though there might be multiple approved drugs in the market, it doesn't really mean that there is a competition. Because usually for cancer patients, they will take 4 or 5 drugs at the same time. And one is not really enough to cure the disease. So we really need a mixture of all of them. So these drugs become oligopolies in a sense that they are able to set the price not based on value that they provide, but based on what the market would bear. They're able to refrain from price competition and maximize their profit by setting their prices very high. Plus, in the States, there is no strict regulatory body to provide a value-based evaluation either. So he also mentioned that even though patent grants are limited in time, usually new drugs are discovered when the patent of old drugs is about to expire. So the new drug companies will again take over the market and set high prices. That's why we often see cancer drugs have lasting high price in the market. So based on these pieces of information, we'll know that the cancer drugs will have a very low number of substitutes, and the substitutability is not very high either, since patients really need a mixture of drugs to cure their cancers. And additionally, cancer drugs are considered to be essential for survival, and they're the necessities, not luxury goods like macarons, right? These are subjected to the economic definition. So in this case, consumers are willing to pay no matter how, because drugs are their only possible cure and they are the only hope, right? So as a result, you'll be able to guess that the PED value will be very low for these cancer drugs, at least below 1, okay? And in fact, you're right. The estimated price elasticity of total demand for specialty cancer drugs was 0.10, according to the recent research finding. So here the sign of PED is positive, because in practice we usually drop the minus sign and consider it as a positive number, even though it should be negative technically, since when you think about the relationship between price and quantity demanded, they're negatively related to each other. But for now, we just use an absolute value to avoid confusion. So this 0.1 is a number, not a percentage, and there are no units. So other studies made by, for example, Dr. Gaynor, Lee, and Volt in the year of 2006 estimate elasticities ranges from 0.6 to 0.8. And in the same year, Dr. Goldman et al., they find elasticities of demand for specialty drugs to range from 0.01 to 0.21. In fact, it's actually near 0, and the number is extremely low. So overall, even though the data slightly differ from each other, the estimates, as we can see, are at the lower end of these findings. So when demand is inelastic, or when PED value is less than 1, an increase in price causes an increase in my total revenue, while a decrease in price causes a fall in total revenue. So let's see how it would be illustrated on an economic diagram here. So since my PED value is less than 1, the cancer drug companies actually fit into our second scenario here. So it shows you the effect of price change on total revenue. So with the price increases from 6 to 8 and quantity demanded drops from 15 to 13, total revenue is given by the sum of A and C. Because how we calculate total revenue is by using price times quantity. So B is the loss and C is the gain part. And since my loss part, in this case, the area of B is smaller than the area of gain, my total revenue falls. So we don't really need any actual mathematical calculation, but if you really want to see a number and if you really love math so much, we can do that too. Okay, so just bear with me here. So my initial total revenue is 15 times 6, and that equals to 90. And final total revenue equals to 13 times 8, and that will equal to 104. And we see there is a gain in total revenue. So it confirms that when demand is inelastic, price and total revenue change in the same directions. And if pharmaceutical companies they want to increase their total revenue, regardless of any social responsibility factors or consideration, it has to increase the price if demand for drug is inelastic. So next time I will focus on the technical stuff and introduce how to calculate the PED by using formula and the range of values for a PED and how it reflects on economic models. right? So I hope you enjoyed this video. I will see you next time. Ciao.